Now, we notice that s to the a has the same dz term as s. That means that s to the a as a price process is perfectly correlated with s. And we saw earlier that the implication of being perfectly correlated is that they must have the same Sharpe ratio. So if we look, so what is the Sharpe ratio? If alpha is the expected return on s, we can calculate the expected return on s to the a. Namely, the expected return on s to the a is the Sharpe ratio. This is the Sharpe ratio of s in parentheses. This is the vol of s to the a, and this is the risk-free rate. Remember, we had a formula earlier that says that if we know the Sharpe ratio of a security and multiply it by its vol and add the risk-free rate, we get the expected return of the security. So the expected return of s to the a is this expression a times alpha minus r plus r. Now, therefore, the risk premium, which is by definition the excess of the expected return over r, is simply a times alpha minus r. Now, from this risk premium, we can then use some earlier work, and that is that we can create a risk-neutral process for s to the a by subtracting that risk premium from the original drift. Namely, we subtract this is now the we just saw a moment ago that this is the risk premium that we calculated, a times alpha minus r, and if we subtract that from the original process drift, we now convert the a times alpha minus delta to a times r minus delta. So this is now the risk-neutral process followed by s to the a. We used Ito's lemma to calculate the process with alpha. We then, by virtue of the Sharpe ratio result, were able to come up with the risk premium for s to the a, and then we have the risk-neutral process for s to the a. So now we can use Module 4 of Chapter 20, where we were able to, once we know we have geometric Brownian motion, oh, and by the way, notice that we have a new dz. This follows the work we did in an earlier module where, by virtue of changing the drift to the risk-neutral drift, we are adjusting the original Brownian motion as well as its probability distribution to produce this new Brownian motion. And once we've done that, we now can calculate the expected value of s to the a. We have the result that s to the a is geometric Brownian motion, and therefore we have a formula that we studied earlier that we can predict what's the expected value of s to the a. Well, it's the value at time 0 times e raised to the drift power. And so from that, we now have the expected value of the, at time t, the expected value under the risk-neutral process of the 8th power of s to the t. Now, we saw in earlier work that under the risk-neutral process, the expected value of s to the a is the forward price. And that's the result from our earlier proposition 20.3, namely that this is the formula for the forward price at time 0 of s to the a. And then the prepaid forward comes just by doing a risk. So the prepaid forward then comes by interest rate discounting the forward price. So the proposition can be proved. It takes a little bit of work because you really need to go through some steps. The ultimate goal, though, is to calculate the expected value under the risk-neutral process of s to the a, because once you have that, that's the forward price. But to do that, we need to figure out what is the risk-neutral process, and to do that, we need the original process, and we need a risk premium. So there's a fair amount of work we had to think through. Let's do some examples of this general result. Here's a simple one with A equal 1. Well, a claim on S, that can't be too difficult to imagine. And what we conclude from the equation is that the forward price, the prepaid forward price, is just S0 e to the minus delta t. And of course, we knew this anyway. The prepaid forward price on stock is the cost of e to the minus delta t shares. Because if you buy that many shares, they will, with the reinvestment of dividends, grow to 1 share at time t. So we knew this, and of course, from this we could apply the other formula that the forward is S0, and then we have an interest rate factor, e to the r minus delta t. Another example would be s to the 0 power, which of course is identically 1, but a can be 0. And if we now do that, we get that the prepaid forward price of $1 delivery at time t is the price of a T-bill. Again, no surprise. It's good to see that a complicated formula, when you introduce two, if you will, trivial assumptions, A equal 1 and A equal 0, gives you precisely back the answers that you expected.